All right, you guys asked for a video of this particular problem. So I went ahead and went through and took one of the bags of 50 and made the counts for all the different colors, including the total was 50. Um, I'm going to go ahead and start this. So the values must be counts for the categories of a categorical variable. So I'll start by saying the values in the table are counts of, um, and this should say category of a category, counts for the categories of a categorical variable, excuse me. So these are counts of colors. So the data should be collected using a random sample or a randomized experiment. So we pulled 50 M&Ms at random from a large bag. So it's a random sample. 50 M&Ms is less than 10% of all M&Ms in large bags. And we need to figure out what our expected count is going to be. So we've got 50 M&Ms. So it says 13% of browns and greens. 13% of 50 is 6.5. And that'll be for both browns and reds. That's not too far off. 14% yellow, so that'll be 7. That's not terribly far off. 16% greens, so that'll be 8. I'm feeling pretty good about this so far. 20% oranges, so 20% of 50 is 10. And 24% blues, so 12 blues. Let me make sure that that adds up. 13, 20, 30, 40, 50. Okay. I always make sure that my expected adds up to how many I have. So the expected values shown below the table are all greater than 5. So we're going to perform a chi-square goodness of fit test. Anytime you're doing a chi-square goodness of test fit, your null hypothesis your null hypothesis is going to be that the proportions of M&Ms, and we'll go back up to this for just a second. So the actual population proportions are the same as the hypothesized or given proportions. Are equal to the proportions given in the problem. And then the null hypothesis, the alternative hypothesis is that at least one I guess I should have said colors up here, of the proportions of colors differs from the stated proportions, or the given proportions may have been a better way to say that. And I'll set my alpha level at 0.05. So show you how this works on the calculator. I'll do it on both calculators. First on the TI. We go into stat and then into test and then scroll all the way down to chi-squared goodness of fit test. It tells us we need to put the observed in L1 and the expected in L2. So I need to go out and do that. So stat, edit. I am going to clear what's in there. Remember, clear, not delete. And so we fill in what we actually have, and then our expected. One of the things, oops, I don't need to put in the 50 because that's the total. And this is not a touch screen, you dingus. Delete that. All right. You can also, I did the calculations in my head, but you could have gone through and done the calculation here. For example, it says it's 13% browns, so you could have gone 0.13 times 50. That would give you the 6.5. So you can do this at the same time. So 6.5. 7, 8, 10, 12. Now I'll go back to stat test and scroll all the way down to D, or you can do alpha D for the chi-square goodness of fit test. There are 1, 2, 3, 4, 5, 6 colors, so yep, the degrees of freedom is 5. And we'll calculate the chi-squared statistic is 3.72 with a p-value of 0.59. And then it also gives you the contributions of each of those. So you can see which one contributes the most. 0.96 being the leader in the clubhouse here. Still looking to see if there's another one bigger. Now, another 0.9. So this was the largest contributor, with the orange being almost as big a contributor. But this p-value is pretty high. This is greater than 0.05 certainly. I'm going to put the degrees of freedom is equal to 6. So here we will reject the null. Oh, sorry, we failed to reject the null. There is no statistically significant evidence that the proportion of various colors of M&Ms differs from those given in the problem. If you're doing this on your NumWorks calculator, so we're in inference, we're doing a test, we go down to chi-square, and it's a goodness of fit test. And the thing I like about this is that you don't have to go, oh yeah, I need to put those in list 1 and list 2. You put them in the list here. But just like the TI, you can do the calculation. So this was 13% of 50, so 0.13 times 50. But since I already have all those, I'm just going to enter them. It tells you that I have 5 degrees of freedom. I'm going to set my alpha level at 0.05. Tell it go on. It gives me the chi-squared value that we have here. It gives me that my p-value is 0.59. And shows you, this is your alpha, right? And I'm way over here. So I'm not at all convinced that this is different. It's not even close. All right. Hopefully that will help you guys out.